Hi guys, sorry I'm out today, but I don't want to waste another day, so we're going to go ahead. I will give you the notes on this lesson. I'll go a little fast, but I know you can stop the recording as you need to and copy things down. So 8.1 is on the Pythagorean theorem, which we've done before, but the new thing with this section is you're going to know how to prove the Pythagorean theorem using things that we learned from last chapter. So we start out with given triangle ABC, which is a right triangle, and we construct an altitude from B to AC, and we'll name this point D. We know C is congruent to itself. Altitudes are perpendicular, which make right angles, and from last chapter we were able to show we have three similar triangles, ABC, BDC, and the small one ADB. So we go through the initial steps to show that. Now since we have similar triangles, we can set up the similarity proportion of the sides. In the first one, I use the long leg for the medium triangle CD over the hypotenuse BC, and that's equal to the long leg for the big triangle BC over the hypotenuse AC. For this proportion, I get that using the short leg AD over the hypotenuse AB, and then I use the short leg AB over the hypotenuse AC for the big triangle. That's just definition of similar triangles. I cross multiply, I use the multiplication property to get these statements right here. BC squared equals CD times AC, and AB squared equals AD times AC. This statement I leave alone. I will use it later. The first statement, I'm going to replace CD right here with AC, the whole hypotenuse, minus AD. So the big segment minus the little leaves me with DC. So I replace it right here. I use the distributive property. AC times AC is AC. AD times AC is AD times AC squared. And now to get the Pythagorean theorem, which is what we want to prove, I make this step. I have an equality, an equation. I have another one here. If I add equals to equals, I should get equals. So I add the left side of the equations, AB squared and BC squared, and write them on the left side. I add the right side of the equations, AC squared minus AD times AC, and I add it to AD times AC. You can see how these are opposites and cancel out, and I am left with the Pythagorean theorem, AB squared plus BC squared equals AC squared. And there's the proof of the Pythagorean theorem. Now using it, oh sorry, this scanned really light. I have legs of 4 and 8 in my right triangle, and I'm trying to find the hypotenuse. 4 squared plus 8 squared equals x squared. 4 squared plus 8 squared is 80. Square root of 80, I can divide 80 into two products, 16 times 5, which gives me 4 square root of 5. In the second example, the right angle is up at the top here, and this should be 6 for one leg, x for my other leg, 10 for my hypotenuse. So the right angle is right here at the top. I have 6 squared plus x squared equals 10 squared. 36 plus x squared equals 100. X squared is 64, x is 8. Notice we're not considering the negative values because it's a distance and there's no negative distance. The biggest mistake I see with these is when you're given hypotenuse, some students still add it to the leg. But remember, when you're given the hypotenuse, that has to go alone on one side. And the last one, the right angle, is down on the right here. Square root of 45 is the hypotenuse. This short leg is 3. 3 squared plus x squared is square root of 45 squared. Square root and squared are inverse operations. I have 9 plus x squared equals 45. And x squared is 36 and x is 6. Then for the word problem, when you purchase large screen TVs, the size they give you is the diagonal. If you know the television is 42 inches wide, You have to calculate the height to see if it fits in your spot. Hypotenuse equals legs squared. So I have to take 2304, subtract 1764, I get 540. Now, rather than just dividing 540 by all the squares you know, the easiest way I do it is just to do a factor tree. I notice 54 is 9 times 6. 9's a perfect square. And then I'd have 54 times 10. 10 has a factor of 2. 6 has a factor of 2, so I'm going to have 4 as a square that divides into 54. 4 times 9 is 36. So 36 should divide into 54. Then I take my calculator, 540 divided by 36, and I get 15. So if that helps, use a factor tree. Otherwise, you can just keep dividing 540 by perfect squares till you hit one that works, which leaves 6 square root of 15, or approximately 23 inches. Next up, Pythagorean triples. Pythagorean triples are just three numbers that make the equation a squared plus b squared equals c squared true, but these numbers have to be whole numbers. We know we can always solve the Pythagorean theorem with square roots, but those are irrational numbers, so we're looking for whole numbers that make it true. So a couple of sample problems here. Are 3, 4, and 5 Pythagorean triples? Well, they are if they make the equation true. We always use the smaller number for the legs because they're the smaller measurements for the triangle. 3 squared plus 4 squared equals 5 squared. Is that true? Yes. So we call it a Pythagorean triple. How about 9, 10, and 13? Well, 9 squared plus 10 squared is 181. 13 squared is 189. False. No, those three measurements do not make a right triangle. They are not a Pythagorean triple. 8, 10, and 6. Don't add up the first two, add up the smallest two squared. 6 squared plus 8 squared, does that equal 10 squared? Yes, that is true, so we have a Pythagorean triple. The next theorem we're going to look at is how to go a step beyond and how to use the Pythagorean theorem to see not only if a triangle is right, but if it is acute or obtuse. So we know if the legs squared equals the hypotenuse squared, it's a right triangle. But if the legs squared are greater than the hypotenuse squared, or the longer side squared, then it's acute. It will no longer be a hypotenuse if it's acute. And if the shorter side squared are less than the longer side squared, then it's obtuse. And we've touched on this before, and we looked at a little bit why before a couple of chapters ago, so this is a review concept. So let's look at some examples down below. I've got 7, 9, and 10. What kind of triangle is it? I take the two smaller sides and I square them, and I compare it to the longer side squared, and I find that 130 is greater than 100. Since the square of the legs is bigger, it is an acute triangle. And if it helps, you can get out a ruler and make a triangle with sides of 7, 9, and 10 to help you visualize this. For 18, 16, and 24, 16 and 18 squared and added together is 580. 24 squared is 576. Again, this is an acute triangle because the smaller side squared is a larger number. And finally, they're going to start throwing at you side lengths with radicals. 3 squared plus 5 squared is 34. But what is the 5 square root of 2 squared? That's our longest side. Well, I square the 5's, I get 25. I take square root of 2 times square root of 2, I get 2. 25 times 2 is 50. 34 is less than 50. I have an obtuse triangle. And the word problem, you're looking to see the shape of a yard. I take the two smaller sides, I compare it to the third side. I get 14,281, which is smaller than 120 squared of 14,400. Therefore, it is an obtuse triangle. Okay, lesson 2. These are probably the most important thing you're going to learn this year in geometry. You will use the special right triangles extensively in Algebra 2, Calculus, Engineering, and beyond. Memorize these, but when I say memorize these, I don't mean don't understand where they come from. but they are so important, they should just come naturally to you. I'm going to explain where these ratios come from, and you should know how to get them, but they should be as natural to you by the end of this chapter as 2 plus 2. So we're going to talk about two what we call special right triangles. The first one is a 45-45-90 right triangle, an isosceles right triangle. And the one on the next page is a 30-60-90 triangle. Now, an isosceles right triangle, we know if both these angles are congruent, both the legs have to be congruent. We're just going to set one of the legs equal to 1. So the other leg is 1, and we're going to calculate the hypotenuse. Well, by the Pythagorean theorem, 1 squared plus 1 squared equals x squared. Our x is the square root of 2. So for this special right triangle, 45-45-90, it has a leg length of 1 and a hypotenuse length of square root of 2. Now, as you recall from last chapter, all triangles with the same angle measurements are similar, and the proportions of the sides will be the same. So this proportion right here, 1 to square root of 2, is going to hold for any triangle that's a 45-45-90 triangle. So for example, if we have a right triangle with two 45-degree angles and the legs are 3, the hypotenuse will be 3 times the square root of 2. If we have a 45-45-90 triangle and the legs are a measure of 14, the hypotenuse is a measure of 14 square root of 2. They're all similar triangles. They have the same ratios. 1, 1, square root of 2. Okay, given one side, how do we calculate the other? Well, if we're going from leg to hypotenuse, it's easy. It's multiplying by the square root of 2. So, sorry this scanned a little bit lightly. You'll probably see it better on your copies. This is a right triangle. The right angle is up here at the top. These are two 45-degree angles, and the hypotenuse is 10. Now, if going from the leg to the hypotenuse, we just multiply by square root of 2, we do the opposite to go from the hypotenuse to the leg. So if I'm given the hypotenuse of square root of 2, how do I get 1? I divide by square root of 2. If I'm given a hypotenuse as 10, how do I get the leg? I divide by the square root of 2. So over on the left here, 10 divided by square root of 2 is my leg. Of course, that's not correct form. We've done rationalizing before. We multiply by square root of 2 over square root of 2. I get 10 square rooted over 2, which is 5 square root of 2. Now, you might go through these steps a couple of times till you quickly notice the pattern. I take the hypotenuse, I divide it by 2, and I multiply it by square root of 2. But you need to know where that comes from, and that's coming from rationalizing the denominator. Let's look at some examples. For number 5, this is a 45-45 right triangle. The right angle's at the peak. The hypotenuse is 24. We want to find the leg. We divide by the square root of 2. We rationalize. We get 12 square root of 24. The next triangle, follow my lines. Hopefully you printed on your sheet, but here we go. The right angle is at the top here. You draw a line here. And here's the hypotenuse where my cursor is moving, and then the other leg at the top. We have a leg of 7. We need to find the hypotenuse. This one's easy. Just take leg times square root of 2, and you get the hypotenuse. Finally, number 7 on the right. The right triangle is this way. Follow my cursor. Here's the hypotenuse, which is a measure of 16, 45 degree angle, right angle on the top right. How do I go from hypotenuse to leg? 16 divided by square root of 2, rationalize, and we get 8 square root of 2. Now, the second special right triangle is a 30-60-90 triangle, and it has its own set of ratios. Hopefully you could see and you could understand that every triangle has its own special set of ratios. We could find these ratios for a triangle with an angle measure of 1 and 89, 2 and 88, 3 and 87, and all the fractions in between. And in fact, somebody did find all those ratios, we put them all together in what we call a trig table. And when I get back, we'll look at this trig table. Here it is, you have it in your packet. These are just all the ratios of the side lengths, only here they're put in decimal form because your calculator will give them to you in decimal form. However, we like to have at least these special right triangles in simplified radical form. If we found the ratios for other measures of triangles in simplified radical form, they would be all sorts of weird things like square root of 17, square root of 13, square root of 41, and have different sort of irrational ratios like that. But we don't make students memorize them all because nobody could memorize all the ratios for 90 different angle measures, but these are used so extensively, the 45-40-5-90 and the 60-30-90, that these we make you memorize. All the other ones you're able to calculate using your calculator, which we will do when I get back. So let's look at our 30-60-90 triangle. So here it is right here. This angle 60, this is 30, it's a right triangle. How do we find these ratios? Well, what we do is we take this right side and we double it. So we have it over here on the other side. Now I have an equilateral triangle. 60, 60, and 2 30s make a 60. If we set our short side to be 1, this whole side is going to be 2, doubled that. And since it's equilateral, each side is 2. So my hypotenuse, we can see, is 2. It's twice the length of whatever the short side is. Now how do we find the long side? We use the Pythagorean theorem. 2 squared equals 1 squared plus x squared. We take 2 squared, we subtract 1. Our x squared is 3. Our x is square root of 3. This is our basic ratio, 1, 2, square root of 3. But remember, it works for all 30, 60, 90 triangles because any 30, 60, 90 triangle of any size is going to be similar to this one, and the side lengths will be in the same ratios. So for example, if we had a 30, 60, 90 triangle where the short side was 4, the hypotenuse would be 8, and the long side would be 4 square root of 3. If we had a 30, 60 right triangle where the short side was 11, the hypotenuse would be 20, and the long side would be 11 square root of 3. Same ratios because all these triangles are similar. Now, how do we calculate? Here, it printed a little light. This is my right triangle. My 60-degree angle is at the top. And on the right side is my 30-degree angle. This is side S. This is side T. And it gives me the long side, which is 5. How do I go from that to finding the short side and the hypotenuse? Well, if to go from short side to long side, I have to multiply by the square root of 3. To go from long side to short side, I simply divide by square root of 3. Similarly, to go from short side to hypotenuse, I double. If you're given the hypotenuse and you need to find the short side, just cut it in half. So from this, I can see that my S, the short side here, is 5 divided by square root of 3. Of course, you have to rationalize that, which gives us 5 square root of 3 divided by 3, but that's the length of your short side. And then to find your hypotenuse, you just double that. So 2 times 5 square root of 3 over 3 is simply 10 square root of 3 over 3. Let's look at a couple examples. Down here, here's the right angle. Follow my cursor at the bottom left. And here's the short side, hypotenuse, long side. The long side is always across from the 60-degree angle. The short side is always across from the 30-degree angle. This variable is an F. This variable is a G. This side length is 4. I'm going from long side here to short side. So my F is 4 divided by square root of 3. Rationalized, that's 4 square root of 3 over 3. And then my hypotenuse, or g in this case, is twice f. 2 times 4 square root of 3 over 3, or 8 square root of 3 over 3. Number 14, my right angle is at the top left. The long side is at the top with a variable x. The left side is the short side with the variable y. Here's the hypotenuse, and it has a length of 6. The hypotenuse is twice the length of the short side, so I divide it by 2, and my short side is 3. My long side, x, is just the short side times the square root of 3, or 3 square root of 3. And finally, number 15, right here is my 60, 30 right triangle. This variable on the right side is a v. The altitude is the variable u. And we've replicated this triangle over here, so this triangle right here has a 60-degree angle here. And the whole length of this equilateral triangle is 12. That means half of it is going to be 6, which means my hypotenuse here is going to be twice 6, which is 12. And that means my altitude here, or my long side of the 30, 60 right triangle, is going to be 6 square root of 3. This should give you enough information to finish Math Excel Lesson 8.1 and 8.2. You don't have any book work for Monday. Ignore what's on the calendar. We'll tackle the book work when I get back next week. Just work on completing Math Excel 8.1 and 8.2. And if you have any questions, feel free to email me this weekend. We will do 8.3 on Monday, so we're not going to spend another day on this. This should be enough information to get you guys started. We'll take some questions at the beginning of class. Have a great weekend.